As we continue into section 5.2, we're going to examine frequency tables, histograms, and frequency polygons. Now, with the example we're going to start with, and this one is from your textbook, we have flow rates from the Red River from 1950 to 1999, recorded at the Redwood Bridge in Winnipeg, Manitoba. And that's a picture there of the Redwood Bridge. Now, when we're talking about flow rates, we're talking about the amount of water that will move past the point in 1 second. So here it's measured in cubic meters per second. Now, as I mentioned in class the other day, the cubic meter, you can think of it as a block that measures 1 meter wide, 1 meter deep, 1 meter high. So if you think of the water that would fill this container, in 1950, 3,058 blocks would have passed by a point in 1 second. So that's the volume of water we're talking about here. All right, just get rid of that. Now, what we're asked, is there a connection between flow rates and flooding? The Red River in Manitoba has flooded many times during its history, and currently there's just a picture, I believe, from 1997, one of the most recent floods. And the river would normally be here, but it's overflowed its banks and went into the surrounding farmland. So we're asked, is there a connection between the flow rate and serious flooding? And if you live in the area, that will be important to you, because as the volume of water increased that was flowing underneath the bridge, what's the potential chances of then having a major flood? Now, as we look at the data here, it's just a collection of numbers, and it can be hard to pick out trends or see patterns in the numbers. What we're going to do is carry frequency distribution, and that's going to involve either making a table, sometimes a graph, and it's going to help us give us a visual picture of the patterns within the numbers. Start with that first, we're going to make a frequency table. Now, to make a frequency table, we're going to set our categories up. We're going to set up bins or categories, and that'll become clear as we run through this. First, we're going to look at our highest flow rate and our lowest flow rate. And our highest flow rate was in 1997, and lowest was in 1981. So in 1997, 4,587 cubic meters of water flowed past in 1 second, and in 1981, you had 159 cubic meters of water. Now from that, we're going to make a connection back to our last lesson, in which we talked about dispersion. And one measure of dispersion is range. And range is the difference between your highest number and your lowest number. And from the lowest number to the highest number, there's a difference of 4,428. So in 1981, perhaps there was a drought, and you only seen 159 cubic meters of water flow in 1 second. And you compare that to 1997, where you had over 4,500 cubic meters of water. So this would represent the difference in the amount of water that was flowing. Now, the number of bins that works out well when you're doing a graph or frequency table, 5 to 10, I wouldn't go any larger than 10. So we take our range and we divide it by 10. And what we have here is 442. Now I'm going to round that up to 450, and you'll see the reason why in a moment. Our lowest flow rate, again, was 159, so I'm not going to go from 0 to 450. And you may think maybe I would go 0 up to 450 and count the number of times I have flow rates there, and then from 450 to 900. But I'm not going to start at 0 because we don't have our lowest flow rate, again, as I just said, was 159. So I'm going to start with a low value of 150, and then this is our spread. So we go up by 450 each time. So we're going to count the number of flow rates we had between 150 and 600, between 600 and 1050, all the way up to 4200 to 4650. And that would take in all of our data. So we go back up to our table, and I'll do this for one with you. We are looking for data now that is going between 150 and 600. If it's 600, we're not going to count it. It's going to include it into the next bin. And I'll explain that in a moment. So I'll look down through here. Anything less than 600, that one. And be careful because it is easy to miss a number as you look down through. Oh, and that one there. And anything less than 600. What I'm going to do, just because I'm able to hear without too much trouble, is I'm going to just cover up the years. The years are not important to us right now. And just so I concentrate on only the numbers that I need. All right, now final look down through. And if we're doing a tally, sometimes it's helpful to do this with a partner. We would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So there were 11 occurrences. Oops. So 11 times when there were flow rates between 150 and 600. And again, if we did see the number 600, we wouldn't include it in this bin. It goes to the next bin at the lowest limit. And so if we had seen 1500, we wouldn't include it in this bin. It would have to go down to this one here. And it's important for you to remember that. Your textbook does it differently. It's not the way it should be done for this course. In 2201, you have to take what will be the highest number or the higher limit and drop it into the next category. Now I'm going to finish the table. All right, now that the table is completed, I did forget to mention this tally section here. If you had someone helping you with it and they were looking down through the numbers and you could count them off as you were going, you could keep track, so you could do a tally. Now, another check you can make here as you go down through. If you look at all your numbers here, there should be 50 numbers in total. And the reason being, because we had 50 pieces of data up here. So that doesn't match. You made a mistake somewhere and left a number out. So the two common errors the students usually make, they put numbers into the wrong bin, say 600 going into this bin down here. Or as they're counting, they miss a number and don't end up with the proper total. So those are things you should check. And if we look at the data that we have here now, let's bring that down. We can quickly see some information here now, and our most common flood rates or flow rates are between 1500 and 1950. Least common will be at 4200 to 4650. These don't occur at all. Next common flow rate between 150 and 600. So you get an idea now of what's likely to happen or easy to occur. Now we're going to take this and make a graph out of it. And the graph we're going to make is called a histogram. The histogram is very similar to a bar graph, except that there are no spaces in between the bars. So to set up our histogram, we're going to take our frequency numbers and place them here. So frequency, take that and move it here. And our bins are going to go down here. And just to save time, I'll write those in. So our first bin started at 150. Now I'm not going to start 150 here. Really will be number 0. And then I start at 150, 600. Okay, before I get too far into this, the space of one bin I'm saying here is going from, think of a number line, going from 0 to 150. But now I'm saying that same space is going from 150 to 600. Now, that causes a problem. You can't do that. So what we're going to do is put a symbol in here, and that means we're condensing all the numbers between 0 and 150. We're going to allow them to fit in this space. What we're going to use is spacing now 450 for everything else. So 1050, 1500, and I'll finish that off. Okay, so now I've completed the label, so the axes for the histogram. Frequency is here, and on the bottom here, this should be flow rate. And that's in meters cubed per second. And we take one last check back at our bins. We'll make sure we have the same ones here. Frequency, our highest frequency is 12, so I gave a little more space up there. And now we're just going to complete each bin. So this one goes up to 12. The next one's at 9. This one, and I will. Whoops. Okay. Just undo that. Again, the idea here is that you will use the graph paper to complete it. You can also use, last lesson I showed you how to use Microsoft Excel. Excel can also be used to complete a histogram, and I can put a link to a video showing you how to do that after. So I'll complete the table. All right, now that we have the histogram completed, we look back and we see here that there are 12 years in which flow rates were bigger than 1950. So here, and there are 12 years in total. So that works out bigger than 1950. Now, the prediction on that then is if the flow rate is bigger than 1950, then you would have a flood that year. And if you look back to the data, each of these years here were in fact flood years. So that's the usefulness of completing a frequency table and then doing a histogram. You also get to see how often particular flow rates occur. Like this one here is very rare to see one of that level. Again, anything bigger than 1950 to see is rare. But if it does go above 1950, you are expected or high likelihood of getting a flood. Okay, that finishes that part of the section.